Hey, everybody.
How you doing, Dr. Trent?
Good, good. A little sleep, a little tired, but doing good.
Yeah, I just got the booster, so I'm feeling a little tired.
Oh, dang. Yeah, I was knocked out for a bit after my booster too. So yeah, hopefully you feel better soon.
Appreciate that.
Hey, Professor.
Hey, Ryan. Sure.
How do you get access to Ansys?
Yeah, I totally forgot. So I apologize. I forgot we were doing it just kind of slipped my mind. We were doing the activity today. So you can download a student version of Ansys. And so if you Google search download Ansys Student, and then they have free versions here for you to use. And so unfortunately, that's going to take a while to download. And so another way to use it. So I would recommend downloading it to your computer, because that's, long term, that's kind of the fastest and fastest way to use Ansys. But another way that you can do it is you can use what's called the virtual machines. And I'll go through this at the beginning of class today. And so if you go to my.fullerton.edu, you log in. If you go to this, the apps here, you can go to the virtual computing labs. And so if you search virtual, come on.
Just remote into one of the other computers.
Basically, yeah. And so if you search virtual here, you'll see an app called Virtual Computing Labs. And then you have to click on this, and so it takes you to this page right here. And so what you need to do is you need to create a reservation for to use Ansys. Okay. And right now, I don't anticipate anyone's using it because it's like 7 o'clock at night. And so you should be able to get through really quickly. And so you click on reservations, you click new reservation, and you need to choose Ansys from this list. And so they have a lot of different images available. And so what you want is ECS Ansys. They might have 2022 already, actually. And so let me see. Actually, they only have 2021. And so you do ECS Ansys 2021. You said you want it now. And then you can specify the amount of time that you want. And so if you want it to last the whole lecture, you can do 2 hours, or most time I do 4 hours just to do that. And then you click create reservation, and then you can just follow kind of the directions on screen. Yeah.
Okay.
Yeah. So I'll go through this at the beginning of class together with everyone. But yeah, it totally slipped my mind. I made the activity today, and then I should have emailed everyone last week to download Ansys, but yeah, it was my mistake. But the virtual computing labs is available for this. Yeah.
Okay, got it. Thank you.
Yep.
Oh, I remember this image.
All right, it's 7 o'clock, so let's go ahead and get started. All right, good evening, everyone. How's everyone doing today?
Wonderful.
Good, good. Wonderful is good. Okay, so today we have our first Ansys activity, and so let me start off just by apologizing because my mind is still kind of back on last semester when we did Ansys so much, and so I forgot that there's some people coming in without Ansys on their computers, and so so I should have sent an email last week to have Ansys ready on your computers, and that was my bad. And so what I'm going to do first thing today is I'm going to show you how you can download and install Ansys on your computer. Unfortunately, it is a very big download, and so it's not going to be ready in time for this class today. But I'm going to show you a different method that you can basically remote desktop into the lab computers that we have on campus, so that you can do the activity with that, because these activities they're kind of best done interactively. So being able to use Ansys is a big plus. So so that was my fault. I should have let everyone know that we're using Ansys today and to have it ready before the lectures. So but I think this way then we can all go through together on how to either download Ansys or get access to it from your personal computer. Okay. All right. And the reason I know I said a lot last week that we're not going to be doing Ansys a lot in this class, but I did want to have one activity very early on because I think one thing that Ansys does really well is that it kind of shows you kind of the entire process. And what I mean by that is that it basically shows you that you can go from a geometry and you take it all the way to the simulation results. And I think it gives a good idea of what you can do with Ansys, what its capabilities are, and just kind of what generally how it's used in industry. And then we're going to spend the next several weeks talking about how is the theory, what is the theory behind this, what is the methodology, what are the algorithms behind doing what we did in Ansys. So I think it's good to have an overall big picture of where we're going, what finite elements is, which I think Ansys does a great job at, before we kind of really dig into the mathematics, we dig into the theory. Okay. Okay. Are there any questions I can answer before we get started? Okay. All right. So let's get started by let me show you how to actually get Ansys on your computer. For those of you who don't have it already, right? And so the nice thing about Ansys and the main reason that we use it in the classroom is that they offer a free student version. And I won't say that it's the best thing ever, because you can't really do anything anything practical with it. And so companies out there aren't using the student version of Ansys for anything. But I think it is relatively fully featured, and that it does give you a chance to try out a lot of different things in Ansys. Without the capabilities of it being fully functional, but it does do a really good job. And so if you want to download the student version, I find that the best way is just Google search download Ansys Student. Okay, and usually the first link will be the one that will take you there. Okay, and so if you want the exact URL, you can see that it's ansys.com/academic/students. Okay. And then you can download the Ansys student version here. Okay. And you can see here that it's free, which is great. Free is good. And the version of Ansys that you want is this one right here, which is just regular old Ansys student. Okay. They have some other tools here, which I think Ansys Discovery I think is a more they kind of change the interface a bit to make it easier to teach. But the interface for this one is different than the professional one, and so I think it kind of is a little bit defeats the purpose, because if you want to learn Ansys to actually use it in industry, you should learn it with the same interface. But if you're teaching finite elements to like high schoolers or like really young undergraduates, then this might be good for you. But anyway, the one that we're using is Ansys Student, so you can go ahead and click download now. Okay, and you go ahead and click on this button right here. And then you can see that the license is going to be good until 2023. Okay, so you go ahead and download this. It's going to download a big ass zip folder. right? And so you just have to unzip it and then run the installer, and then you can go ahead and do that. But that's going to take a while, and so for the long run, I would definitely recommend that you do this because it's it's much easier to use Ansys on your own computer. But for today, it's probably going to take the entire length of the lecture just to download and install it. So for today, there's another tool that you can use, okay, and it's called the Virtual Computing Labs. And so to utilize the Virtual Computing Labs, basically what it is it'll allow you to remote access or remote desktop into a lab computer that we have on campus, right? And so the easiest way to access it is to go to your My Caltech Fullerton portal. Okay, so you go to my.fullerton.edu, you log in with your your campus ID and your password, and you come to this folder right here. Okay, and then on the apps filter, you're going to search virtual. Okay, and as soon as you start typing it, it should automatically come up, right? And so you're going to click on Virtual Computing Lab, right? And so after doing so, it's going to take you to this page right here, right? And then it's going to allow you to book a reservation, okay? And so you're going to click on Reservations here, okay? And then after Reservations, you're going to click on this button here for New Reservation, right? So you're going to click on New Reservation, okay? You're going to select Ansys here from the environment. And so you can see here, there's lots of different environments that you can choose from. But the one you want is the one with Ansys. And so it's called ECS Ansys 2021 R1 4x10. Okay. And you want to say that you want it now. And you want to use it for at least 2 hours. And so if you want to make sure that it doesn't shut you off in the middle of lecture, make sure that you select this for 2 hours right here, or you can go up to 4. Okay. All right. And so once you've done that, you can go ahead and click on Create Reservation. And so it should finish up really quickly because, honestly, there should be no one else using the Virtual Computing Lab except for us, okay? And so you can see here that it's still pending, but in about 1 minute, this is going to be activated. And so once this is activated, you can go ahead and click on that. There's going to be a button that said to open reservation or something, right? Although now it might be a little bit busy because we have a lot of people from this class logging on at the same time, but but basically, anyway, once this opens up, then you can go ahead and open up the reservation, and then from there you can just follow all the instructions on the screen. Okay, so that's it. So this is done, and so now that it's created our reservation, we can go ahead and click on Connect. Okay.
Professor, I don't on the reservation it doesn't say connect.
Does it still say pending?
No, it doesn't have pending. It just says delete reservation and more options, but nothing to the left of delete reservation.
Okay, maybe you have to just kind of reset it. So go ahead and delete that reservation and just create a new one and see if that helps. Yeah. Okay. All right, so you can go ahead and click on Connect. And there's two things that you need. There's two pieces of information that you need from this screen right here. And so you're going to click on, or you're going to need the user ID, and you're going to need the password. Okay, because that's how you're going to log into the virtual computing. Right. And so from there, you're going to click on this button right here called Get Rdp File. Okay. And so it's going to download a file for you. And so you can go ahead and save it. Right. And so you can go ahead and click on this. Right. And so it's going to ask if you want to connect. And so it says the publisher can't be identified. I don't know why they haven't fixed this because I've been using it for 2 years now. And so you can go ahead and click Connect anyway. Okay. And then I'm not sure if you guys can see this, but then a window will pop up where it says to enter your credentials. And then from there, you're going to input the password that they gave you, right? And so for me, it's LDAEBQM or BQKM. Okay. And you can go ahead and click OK. And then once you click OK, it's going to open up a remote desktop on your computer. Okay. And then it's going to take, it might take a couple minutes to boot up. But from there, you should be able to use Ansys from, Ansys from that screen. Right? So I'm not going to do it on my computer just because, I already have Ansys on my desktop and it's going to overload my computer. But that's kind of the basics of how you create a reservation on the virtual computing labs and how you open up Ansys like that. Okay. All right, so for those of you who are doing the virtual computing labs, was everyone able to connect, or are you having issues with the creating the reservation. Ryan, did making a new reservation, does it say pending at least or connect?
Yes, it's 6 now. Thank you.
Okay. Okay, great. Awesome. Okay. Yeah, and then once you're inside the virtual computing lab, you want to open up Ansys Workbench. And so you know, when you click on the start menu right here, you're gonna find a folder called Ansys R 2021. And so if you click that, you know, there's going to be a bunch of programs in there. And the one that you want is called Ansys Workbench. And so it's going to be the one at the very bottom. Yeah, it's going to be this one. It's going to be this one right here, right? And then once you open that, you should be greeted with a, oh, let me go ahead and create a new one. I was testing stuff out earlier. Okay, and so you should be greeted with a you know, with the window that looks like this basically. But yeah, so I'm gonna give an introduction to the activity, and so, you know, just to give everyone a chance to catch up for those of you who are connecting to the virtual computing lab, and then, you know, once everyone's kind of caught up, then we can start the activity. Okay, but for now, let me go ahead and introduce the activity, right? And so you know, if you've taken a finite element course with me before, either 410 or if you're coming from 540 last semester, you know, this activity will be very familiar to you. And it's kind of, you know, it's kind of almost tradition that this is kind of the first activity that everyone does with Ansys. And so basically I call it plate with a hole, and where we basically are simulating a two-dimensional plate, and we're going to be applying a force, a tensile force to it. And we're going to see how the plate is going to deform and what the stress distribution within the plate is going to look like, okay? And so here are the dimensions of the plate. And so we have a rectangular plate with a certain length and a certain width, and the hole in the middle has a diameter little d, and we're going to be pulling on the plate with the tensile pressure capital P, all right? And so, you know, all the dimensions are given here, which we're going to input into the program, okay? And this activity is basically going to walk you through the entire Ansys process. And so we're going to be creating the geometry. We're going to be assigning the material properties. We're going to be, you know, meshing the geometry, applying boundary conditions, specifying outputs, performing the simulations, and viewing the results. Okay. All right. And so, you know, just like I mentioned before, you know, the goal of this activity is to basically kind of be your first introduction to Ansys. And so, you know, we're going to be learning a lot of, you know, where all the buttons are, you know, what settings to put for what, and, you know, how to conduct a really basic analysis in Ansys. Okay. And again, and what I hope from this activity is that this gives us context, you know, for the rest of the class, because, you know, we're going to be doing a lot of the math and theory of, you know, what we're striving for, because, you know, it always helps to, you know, when you're kind of in the trenches, you know, working really hard on the theory and the math, to know, like, you know, this is what I'm fighting for. This is what the end goal is. Because I think, you know, a lot of the mistakes that a lot of other finite element courses make is that they kind of just start right away with all the really intense math stuff. And I think, you know, it's not so much later that people actually get the sense of, like, oh, you know, this is what finite elements is. And so, you know, I want to give you a sense of that first, you know, a taste of that first, you know, before we really start, diving in. Okay. And, you know, if you fall behind, or if you want to move ahead from where I'm going, then, you know, the PDF that I've uploaded onto Canvas, this has all the instructions in sometimes in painful detail. And so if you want to go ahead, or if you need to catch up, you know, I would say just follow the PDF, and the PDF has, you know, all the information for you, you know, with everything. And so I'm basically just gonna be following the PDF just very closely. Okay, and so are there any questions I can answer before we get started? Right. So everyone on the virtual computing labs, was everyone able to log in and open up Ansys okay on there? Or is it still loading?
I'm good.
No. Good. Okay. All right. Okay. So let's go ahead and get going. All right. And so if you open up Ansys Workbench, you know, this is the first thing that you're going to be looking at, right? And so the first step that we need to do is we need to select the type of analysis, right? And so the thing with finite elements is that you can use finite elements to solve for a lot of different types of physics, a lot of different types of systems, okay? And so basically, if it's modeled with the differential equation, and most physical phenomena are, then you can solve it using finite elements, right? And so you can see here we have things like electrical, we have things like fluid flow, we have thermal, we have structural, we have modal, magnetostatic, lots of different things. But the one that we're going to be using for this activity is static structural. And so let's go ahead and click on static structural, and you can either double click it or you can click and drag it to the area here. Okay. And then that's and that's it. And so now we're basically telling Ansys that we're going to do a structural simulation, and it's going to be static. And so what that means is that it doesn't change with time. Okay. All right. So the next thing that we're going to do, and this step is really important, is we need to specify to Ansys that we're going to run a 2D simulation. Okay. Because by default, Ansys assumes that you're going to run a 3D simulation. Which is not incorrect. Most of the time you do want to run a 3D simulation. But for this particular activity, just because it's a very simple geometry, all we need is 2 dimensions, okay? And so to change the analysis type to 2D, we're going to right click on geometry here, and you're going to click on properties, if the right-hand side of the screen doesn't show up already. And then you're going to go to this entry right here called analysis type, and then we're going to change that to 2D. Okay, so you can see by right now the default is 3D, and so we're going to change that to 2D. Okay, so that's really important because if you have the simulation in 3D, it's gonna mess some things up. Okay, all right, everyone with me so far? Everyone good? Okay. Silence is yes. Okay, so let's go ahead and keep going. Right. So now that we've specified the analysis type to 2D, let's go ahead and specify the material properties, right? And so whenever you run a finite element simulation, remember you're doing a simulation or a prediction on a real life material or real life geometry, right? And so you have to also include the material properties of that material, just to make sure that it's going to be behaving correctly, right? Otherwise, you might be accidentally simulating a candlestick made of steel or something like that, and that's not going to be realistic, right? And so to assign material properties, we're going to go double click on engineering data here. Okay. Right. And you can see here that the only material that you have loaded so far is structural steel, right? And so you can look at the values for structural steel here, right? And so the main 2 properties that we're interested in are the Young's modulus and the Poisson's ratio, okay? And so you can see the Young's modulus of structural steel is 2 × 10⁻11 pascals, and the Poisson's ratio is 0.3, okay? All right. And so in this particular case, we are we're happy with structural steel because this already has the material properties that we need. But in future activities, I'm going to show you how to create a custom material where you can specify your own Young's modulus and your own Poisson's ratio, or you can use the material property from the library inside Ansys as well. Okay. All right. So for now, I'm just going to go ahead and close that, and then close out of the close out of that. Okay. And the next step that we're going to do is we're going to construct the geometry. And so we're going to go ahead and right click on geometry here. And we're going to click on this button right here for new design model or geometry, right? And so don't click on space claim, right? And so space claim is a different program within Ansys, but we're going to use just kind of the basic CAD software within Ansys, which is called design modeler. Right? So let's go ahead and click on design modeler. And it's going to take a couple minutes to boot up. So the interesting thing about Ansys is that it's not just one program. It's actually a collection of lots of different, lots of other programs that kind of all work together to, they all kind of work together to produce a finite element simulation. And so part of that is, Ansys has its own CAD software that it includes with, with its, with this package. And one of those is Design Modeler. Okay. And so once Design Modeler opens, you should be greeted with the following screen. Okay, so it should be mostly blank, but you should have, a bunch of stuff that's selectable here. Right? So was everyone able to open Design Modeler? Okay. All right, and so let's go ahead and start constructing the geometry. Right? And so in order to start constructing the geometry, we need to first sketch it. And so to sketch the geometry, we need to select a plane first. And so I'm going to go ahead and left click on XY plane, and I'm going to center the view on the plane. And so since we want to view the XY plane, I'm going to click on this blue Z arrow right here. Okay, and so that's going to center the view on this, and to make it easier to sketch. Okay, all right. But before we start sketching, I want to change the units of this because right now we're in meters. And that's kind of way too big for us to sketch our geometry. And so I'm going to change the units here to millimeters. And so to change the units, you're going to come up to the top of the screen and click on units right here. Okay. Right. And then this will allow you to change the primary length unit that that Ansys uses. And so for this particular activity, the most convenient unit is millimeters. And so I'm going to go ahead and select on millimeter here. Right. And so with the millimeter selected, now everything is in millimeters, which is great. Okay. And so now we're going to start constructing the geometry. Okay. And so constructing geometry is for this case is fairly simple because it's just a rectangle. And so I'm going to go to sketching right here. Right. Because right now we're sketching in the XY plane. We're going to click on rectangle here, okay? And I'm going to go ahead and click and draw our rectangle, right? And so you don't have to be that precise because we're going to dimension this anyway. But go ahead and click and drag and draw a rectangle in the space that we have here, okay? All right. And so now now that we've drawn our rectangle, we can go ahead and add dimensions. Okay, and so if we look back at the project specifications here, we can see that the length of the rectangle is 300 millimeters, and the width or the height of the rectangle is 200 millimeters. Okay, so let's go ahead and specify that within Ansys. Right? And so to add dimensions to a sketch like this, we're going to go ahead and click on dimensions. Okay. And this is going to allow us to specify the dimensions of our rectangle, right? And so right now we're going to set just general dimensions. So first thing we're going to do is we're going to set the length of the horizontal side. So I'm going to go ahead and click this and click up, okay? And then we also want to set the length of the width or the height. And so I'm going to click on the height of the rectangle and click out just like that, okay? And so this part's a little bit confusing because I think, if you're coming from a program like SolidWorks, I think most people are kind of accustomed to, after you create a dimension like this, that you can just kind of directly specify what the value of that dimension is, right in line with that. But the way Ansys does it is a little bit different. And so after you create a dimension like this, it actually creates, the dimensions here. And this is actually where you're going to modify it in the bottom left detailed view of the screen. And so first thing we're going to set here is the horizontal length. And so we have H1 here. And so right now the length for this is about 93 millimeters. And so let's go ahead and specify that to be 300, which is the length of the plate of the rectangular plate that we're using. Okay. And then next, let's specify the height. And so the height here right now is about 61 millimeters. And so let's go ahead and change this to 200 millimeters. Okay. And so now we have, a rectangle that looks like that. Okay. And so now the rectangle is the appropriate size. But the next step is to actually center that rectangle on the origin, just to make it a little bit easier for us to draw the hole. Okay. All right. Any questions on this so far? everyone able to keep up? Okay. All right. So I'm going to assume that everyone's doing okay. All right. Okay. And so the next step in this process is to center this. Okay. And so to do that, we're going to use different dimensioning tools here, right? And so the first tool that we're going to use is a horizontal dimension. And so that's going to specify the horizontal distance between two vertical lines. Okay. And so let me go ahead and click on horizontal dimension here. And I'm going to click on the left-hand side of the rectangle. And the other thing I'm going to click on is the y-axis right here. Okay. And so by doing that, you can see I've created another dimension here, which they've called H3. Okay. And we want to set this so that the rectangle is centered on the origin. And so we're going to set this dimension here to be half of what the length of that side is. Okay. Okay. And so the since the side is length 300, I'm going to set this horizontal dimension here to be 150, just to make sure that we're kind of right in the middle of that. Okay. All right. Next, we have the vertical dimension. And so just like we did with the horizontal one, I'm going to click on vertical. And on the one hand, I'm going to select the bottom surface of the rectangle. Next, I'm going to select the x-axis. Okay. And so that's going to create a vertical dimension here, which right now it's about 28.9 for myself. Right? And so I'm going to set this equal to about half the height of the rectangle, where the height of the rectangle is 200. And so I want to set this to be 100 millimeters, just like that. Okay. Oh, and if you're curious about how to pan within Ansys here, what you do is you hold down Control on your keyboard, and if you have a middle click on your mouse, you can go ahead and hold that middle click, and then you can go ahead and pan. And so that can be useful for some things. Okay. All right. Any questions on this so far? Okay. All right. And so the last geometrical detail that we need to model here is the hole. Okay. And so to model the hole, we're just going to draw a circle right in the middle of the plate. Okay. And so we're going to go back to draw here. And so from dimension, you're going to go back to draw, and then you're going to draw a circle, right? And so you're going to click on circle. You're going to click on the origin of the plate, okay? And you're going to click and drag it out. Okay. It doesn't really matter how far you drag it out, because again, we're going to dimension this circle. Okay. Right. So we're going to click and drag it out just like that. You're going to click on dimensioning, and so we're going to click on the circle here. Okay. With the general dimension tool, and then we're going to specify the diameter of the circle. Right. And so for our case, we have a diameter of 50 millimeters. Okay. So I'm going to go ahead and specify that. Okay. So 50 millimeters. Okay. And it's going to make our hole a little bit smaller, just like that. Okay. All right. And so if you're comparing the image of your rectangle compared to what's in the PDF, the PDF one's going to look a little bit different because those screenshots were taken with different dimensions of the hole. But for this particular activity, I want you to use 50 millimeters for the diameter of the hole. Okay. All right. Any questions on this? Okay. All right. And so now that we've done all the sketching, we actually need to turn this into a surface that we can actually use for Ansys, because right now this is just all this is right now is just a sketch, and so we haven't converted this into a surface or anything. Okay. And so to convert this into a surface, we're going to go back to the modeling tab here. Okay. So make sure you click on modeling, right? And so it's away from sketching. And if you click on the plus arrow of the XY plane, you can see here that we have a single sketch, which is sketch 1. Okay. And that sketch, represents our rectangle with a hole, right? And so what we need to do here is we need to basically convert this into a surface. Okay. And so to do that, we're going to go up to concept up here. Okay. And then you're going to click on this entry right here called surfaces from sketches. Okay. And so what this basically does is that it takes a sketch and it turns it into a 2-dimensional surface, which we can use for finite elements. Okay. So let's go ahead and click that. Okay. And so it's going to create a new object down here called, surface sketch 1, right? And so what we need to do is we need to specify the sketch that we want to turn to a surface. And so you're going to click on sketch 1 right here. You're going to click apply. Okay. Right. And so now this surface sketch tool is locked onto sketch 1, right? And the last thing you're going to need to do is you're going to need to specify the thickness of your plate. Okay. If you go back to the PDF, you can see here that we have a thickness of 5 millimeters. Okay. All right. So let's go ahead and specify that. And so we have a thickness of 5 millimeters. Okay. Right. So now that we have our rectangle drawn up, we have our hole, and we specify the thickness. Right. The last thing we need to do before we return to Workbench is we need to hit generate. Okay. And so generate is a good, whenever you're kind of making modifications to a geometry and you're creating surfaces, the generate tool there will kind of finalize everything and make sure that it registers with Ansys, right? And so you can see here that once I click generate, it's actually going to fill in the surface, right? And so now we have this kind of surface sketch, with a hole in the middle. Okay. Oh, is the remote, the remote's being really slow. Okay. Yeah, I apologize again. I apologize because I normally what I do before the first activity is I let everyone know that we're going to do Ansys, and I send out instructions on how to download it. And so that was my bad. I should have last week let everyone know that we're doing Ansys and then send out instructions to download it. So I apologize for those of you who are using the virtual right now. If you can't. If you're not able to do it, but the lecture is being recorded, and then the activity is detailed pretty well in the PDF, and so you can and so you can go ahead and follow that as well. And so if you're having trouble with the virtual computing lab right now, maybe just kind of sit tight and just kind of watch the Zoom call. And then just kind of replicate it when you're, once you're able to download Ansys Student onto your computer. Yeah. Okay. Any questions on this so far? Okay. All right. And so if you're done with the geometry, we can go ahead and close out of Design Modeler. Okay. And so remember, Ansys is a collection of different programs, and so if you close Design Modeler, it's not going to it's not going to close the whole thing. It's just going to open up a different program, right? So we're going to go ahead and close Design Modeler here. Okay. And then we're going to return back to Ansys here, right? And then we're going to double click on Model, okay? And so this is going to open up a different Ansys program called Ansys Mechanical, and this is where we're going to perform most of our analysis. And so this is where we're going to do the meshing. This is where we're going to do the boundary conditions. And so on and so forth. Okay. Okay. And so just like Design Modeler, this takes a couple minutes to load up. And so, I always have to stall for time when this happens. Right, so it's getting there, it's getting there. All right, so we're there. And so if you're opening up Ansys for the first time, it might give you like an ad or something like that to like follow Ansys on Instagram or something like that. And so if you get that, just go ahead and go to the left-hand side menu right here to the outline, and then just click on geometry, and then that should bring you to this screen right here where you can actually view the the geometry that you're doing a simulation on. Okay. All right. And so now that we're at this geometry right here, now we're going to go and actually perform the simulation on this. Okay. And so the first step that we're going to do is we're going to mesh the geometry. Right. And so if you remember from our introduction slides on last Monday, you know that an important part of doing finite elements is to discretize it. Or in other words, we want to break up the geometry into a bunch of simpler shapes so that we can run our analysis. Okay. And so to do that, we're going to go ahead and run our mesh. And so if you go to the left-hand side of the screen here with the outline, you can see here that we have an entry called mesh. I'm going to screw that up. Let me draw that better. Okay. Okay. And so from this mesh right here, we can from this button right here, we can go ahead and mesh our geometry. Okay. And so to produce a mesh, you can go ahead and right-click on mesh, and then you can click on this button right here called generate mesh. Right. And so what this will do is this will generate the mesh for you. Okay. Okay. And so it's going to take a couple minutes or a couple seconds. Right. And so you can see here that we have a very, very basic mesh on our geometry. And so, you know, we can see here that, you know, from our big plate with the hole, it's broken it up into a bunch of little squares that kind of litter around the geometry. Okay. And so now, you know, this is in a position where we can run a simulation on this because we've discretized the geometry, right? And so we've performed kind of the first step that we need to do in order to produce a finite element simulation. Okay. But you know, right now this mesh isn't great because you know, because these elements here are all pretty big, right? These are fairly big, you know, chunky elements here. And you know, if you want to run a finite element simulation, it's usually a good idea to refine your elements to make sure that they're smaller. Okay, and so there's lots of different ways that you can do this. And so you can you know, one easy way to do it is to change the element size. And so you can go ahead and click on mesh on the left-hand side right here. Okay. And then in the bottom left of the screen, you should see the details view of the mesh, right? You'll see this option here for element size. Okay. All right. So right now it's set at the default, which is about 30 millimeters, which is pretty big. And so I'm going to go ahead and change this. And so instead of 30 millimeters, let's go ahead and set this down to 10 millimeters. Okay. All right. And so once we've changed the element size, we can see that the mesh itself has changed. Okay. And so let's go ahead and update it. And so to update your mesh, you can right click on mesh right here and click update. Okay. And you can see here that we have a much more uniform, you know, a much more refined mesh here where the elements are much smaller than they were before. And so this is looking great. And so, you know, usually a good rule of thumb whenever you're running finite elements is to try to refine your mesh as much as you can, you know, without really killing your computer, because the more refined your mesh is, the more accurate your simulation is going to be. But you have to do it kind of carefully, because if you refine the mesh too much, and I'll go down a little bit just to kind of show you. But if you refine the mesh too much, you know, you might actually crash your computer, because you know it's just going to take too much memory for the program to process. But I can take this down a bit more just to show you. So let me go ahead and take this down to, you know, let's say a mesh size of 3 millimeters. Okay. And you'll be able to see, you know, how long it's going to take my computer to mesh this geometry, you know, with a really refined mesh. Okay. And so the mesh itself is going to look great. You know, it's going to look really refined. You know, you can see here that, you know, now this mesh is really, really refined, you know, but it's going to make the simulation a lot more expensive. Okay. And it's a little bit too much cost of what we need for this very simple one. So I'm going to go ahead and change this back to 10 millimeters. Okay. And then update the mesh again. Okay. And then now we're back to our good mesh here. Okay. All right. One other thing that you have to do with the mesh is that we have to change the element order. Okay. And so we're going to go to this setting right here called element order. Okay. And so, you know, we'll be talking about element order a lot in this class, about what that means and, you know, and what that means for the theory. But, you know, it's an important consideration to, you know, whenever you're running finite elements. Okay. And so basically you have two options for element ordering. So if you click on this button for program controlled, you can either select a linear order or a quadratic order. Okay. And so for this simulation, a quadratic order is usually the best. Okay. Unless you're running like a thermal simulation, usually quadratic is the way to go. And so now that we've changed it to quadratic, let's go ahead and update our mesh. Okay. Whenever you change anything in your mesh, you have to update it to make sure that the changes stick. Okay. And then once you're done with that, you have a our mesh is complete, and so we have a decently refined mesh, with a quadratic order, and we're good to go, for the simulation. Okay. Any questions on this so far? Okay. All right. Actually, no, I forgot one thing about the mesh. And so one thing that we're going to do with this mesh is we're going to add what's known as refinement. Okay. And so refinement will basically allow us to refine our mesh in a very, very small area. Okay. And so in this case, we want to refine our mesh around this hole right here. Okay. All right. Just because, after we apply the loading, after we apply the constraints in the loading, the stress is going to concentrate around this hole, right? And the simulation results will reflect that as well, right? Generally speaking, whenever you're running a structural simulation and you have an area where you expect the stress to concentrate or to spike up, you want to have some additional mesh density there to make sure that you get an accurate result, okay? And so in this particular case, we're going to expect that the mesh or that the simulation results or the simulated stress is going to spike around this hole. And so I'm going to refine the mesh just in this area to make sure that we get an accurate stress computation there. Okay. And so to add refinement, we're going to right click on mesh. We're going to go ahead and click insert. And then after insert, you're going to click on refinement. Okay. And so it has this kind of like Triforce looking symbol to it, right? And so if you read the tooltip for refinement, basically it basically allows you to specify the number of times you want an initial mesh to be refined. Okay. And so you can specify the refinement controls for face, edges, and vertices. Okay. All right, so let's go ahead and click on refinement here. Okay. And then let's go ahead and select just the inner surface of this hole. Okay. And so we want to select just the just this line right here, right? And so if you're having trouble, and so if you by default, you might be selecting this entire surface, okay? But we don't want that. We don't want to refine everywhere. We just want to refine around this hole right here, around this edge. And so to do that, you have to make sure that you're on edge selecting mode, okay? And so if you go to this part of the screen right here, okay, you can choose, how you want Ansys to select different parts of your geometry. Okay? And so in this particular case, we want to select an edge. And so I'm going to go ahead and click on the second option here. Okay? Or you can do Control E on your keyboard. That's fine too. Okay? And so we're going to go ahead and click on this hole. I'm going to go ahead and apply that. Okay. So now we're applying refinement around that edge. Okay. And you can choose the level of refinement as well. Right. And so in this case, I only want to do refinement level 2. Okay. And so that's going to make the mesh twice as refined as it was before. And we go ahead and update our mesh. Okay. And so you can see here now that we have a refined mesh around here. So, in this area around the hole, you can see here that the elements here are smaller, right? And so smaller elements, remember, leads to a more accurate solution. And so that's great because now, in this area here where we expect the stress to concentrate, we're going to get a much more accurate simulation in that area. Okay. Any questions on this so far?
Yeah, Professor.
Yep.
I've been wondering about this since last semester. Since we added the refinement there around the hole, in order to accomplish that, like we got a bunch of those weird looking triangles. So like, would we have been better off just making the entire mesh smaller if our computer could handle it rather than going for a refinement just around the circle? Because like, wouldn't the triangular elements be more difficult to calculate for the computer?
Yeah, it's a good question. And so Yeah, and so basically what Jake was referring to is, you have a lot of these kind of weird looking elements here, that are kind of triangular in shape compared to the uniform ones around there. Usually these elements here that have a weird shape are not that big an issue, as long as they're not really distorted, where you have kind of a really skinny element like this. These are still relatively, they still have some shape to them, and so that's usually fine. But if your computer can handle it and you can tolerate the increase in cost, then you can go ahead and refine this as much as you can tolerate. And so you can go ahead and split this up into much smaller elements, and that'll accomplish the same thing. It'll just be a lot more expensive. And so the nice thing about the refinements is that you can concentrate the cost. You can concentrate the mesh density in the areas that you want, while trying to keep the overall cost of the simulation down. And so yeah, so both options are fine. And so and if you can tolerate the increase in cost, either you have a really powerful computer or you're running this on a supercomputer anyway, then just go for it, because there's no besides the cost savings, there's no really inherent benefit to just refining in a single area. Besides just the overall cost. But these elements are usually fine, because they're not that distorted. They might look kind of funky, but their overall shape is still okay. So I think if you measure the skewness of these elements, they'd still be very unskewed. Yeah. Okay.
Thanks, Professor.
Yep. All right. And so the next step in the process is we need to apply boundary conditions. Okay. And so the boundary conditions are going to be our loads and our constraints, right? And so whenever you run a simulation, you have to constrain the geometry. And so for a structural simulation, what that means is that you have to apply some fixed supports at certain areas. And so, for our plate right here, we can see that we have a fixed support here on the left-hand side, okay? And so basically what we're assuming is that this plate is welded to this wall. And so if you pull on it, it's gonna stay attached right here, okay? All right, so let's go ahead and apply that boundary condition first. And so to apply boundary conditions, you're going to right click on this entry right here called static structural A5, right? And go ahead and click on insert. And then the setting that you want to specify here is fixed support, okay? And so you can go ahead and click on fixed support, right? And if you read the description for this, you can see that we're inserting a fixed support boundary condition to prevent the selected geometry or mesh entity from moving or deforming, right? And so that's perfect, because we want the left side of this geometry here to be fixed, and so we don't want it to move. Okay, so we're going to go ahead and click on fixed support. I'm going to go ahead and click on the left-hand side of the geometry here. Okay, so I'm going to go ahead and click apply. Oops. Right. And so by hitting apply, we're basically applying a fixed support here on the left. And so after we run our simulation, that left-hand side is not going to move. And and you'll see that in the simulation results as well. Okay. All right, and so the next thing we're going to do is we're going to apply a tensile pressure on the right-hand side. Okay, and so we're going to right-click on static structural A5 again, and we're going to go to insert. And the next thing we're going to add here is a pressure force. Okay. All right, and so we're going to go ahead and select pressure. Okay, so this is going to create a pressure object here on the outline menu of our simulation. Okay, and then we're going to select the right-hand side of the plane. Okay, so we're going to click on the right-hand side here. We're going to go ahead and hit apply, right? And then now we need to specify the magnitude of the force. Okay, right. So, but before we do that, we're going to change the format of the force here to be a little bit more convenient for us to apply, right? Because right now the force that we apply is going to be defined as normal to the surface, right? And so what that means is that when we input a magnitude for this force right here, it's just going to apply that force normal to whatever surface that we selected. And so let me go ahead and click on this and specify 100,000 or 10,000 megapascal. Okay, and so what that's going to do, let me go ahead and center this view. Okay. What that's going to do is that it's going to take our force and apply it compressively, just like that. Okay, because we basically selected this surface as the one we want to apply our boundary condition. Okay, and because we're applying that force normal to that surface, this is essentially what it means. Okay, But for this particular case, we want a tensile force. And so, having it normal to the surface here is not that convenient. Okay. One way that we can accomplish that is we can just set this magnitude here to be negative 10,000. Okay. And so the negative 10,000 means that it's going to apply the force in the other way. Okay. And so that can work. And so you can do that for this particular example. But I'm going to show you another way to apply this force, which I think is a lot more convenient just in general, which is to specify the force according to its components. Okay. And so on this defined by square here, instead of applying a normal to, what we're going to do is we're going to change this to components. Okay. And so what this will do is this will allow us to specify the X and Y components of the pressure force independently of each other. Okay. And so since we want the force here to be just in the positive X direction, I'm going to go ahead and insert a mode here of 10,000 megapascal. Okay. Let me just double check that that's the right magnitude. Loading P, yep. Okay, so the loading P here, we can see it's 1 times 10 to the 4th megapascal. Okay. And so that's 10,000. Okay. All right. And so now that we have the mesh figured out, we have the boundary conditions figured out, we're almost ready to run the simulation. Okay. But any questions on this so far? Okay. All right. And so the last thing that we're going to do, before we run our simulation, is that we have to specify what outputs that we want to view. Okay. Because when Ansys computes a simulation, there's lots of different results that it can show you. And so, we have to specify which results that we want Ansys to actually show for us, right? And so to specify our outputs, we're going to go ahead and right click on solution A6, okay? We're going to go to insert, okay? And you can see here that we have a ton of different options available for us in order to specify our outputs, okay? And so one output that I almost always look at whenever I run a structural simulation is the total deformation, okay? And so I'm going to go ahead and click on total deformation there, okay? And then next we're going to click on insert, and then we're going to go to the equivalent stress, okay? And so the equivalent stress is a measure of the structural stresses that are occurring within the material, okay? And those stresses occur just in order to make sure that the material is, or that the geometry is still in static equilibrium. Okay, so let me go ahead and click on that. Great. Right, and so now that we have all the outputs specified, we're ready to run the simulation. And so to run the simulation, you can go ahead and click on this nice giant button right here called Solve, right, with the lightning bolt. And so that's going to go ahead and solve our simulation. Okay. And so it might take a few seconds or a minute or two, depending on how powerful your computer is. Okay. And if you want to check the progress of your simulation, you can check the bottom left corner of the screen. Okay. So you can see here, mine's just about done. Oh, error messages. Okay. Let's see. Result file cannot be opened. All right, so normally when you run the simulation here, then it should show you results. And so when you click on this, you should see a color contour plot of the results. Okay. Let's see. Result file cannot be read. But why can't it be read? Ansys always gives me these errors in the most inopportune moments, unfortunately. Okay. And so, I don't want to spend too much time debugging this. Hopefully you guys aren't viewing the same error. I think my license might be a little bit out of date, and so that might be the reason why it's not solving. Actually, let me go ahead and do this. Let me go ahead and suppress this. Let me try one more thing, and then we'll and if not, then I'll just kind of talk through the rest. Okay, same error. Okay. All right, so I apologize for that, but normally it doesn't do that. Ansys is very temperamental. All right. All right, and so if you're able to run the simulation and you can view the results, you should see something like this, where if you click on the total deformation, it'll give you basically a heat map here of showing you what all the deformations are. Okay, and so I want to highlight a couple of things to you in this figure. Right? And so the first thing I want to highlight to you is that you can see that the left-hand side of the figure is blue, right? And so a blue figure here, a blue color here, corresponds to 0 deformation. And so that side of the plate is not deforming at all, right? And that makes sense because remember the boundary condition that we applied here on the left-hand side, right? And so the constraint that we applied was a fixed support, and so we're basically not allowing that part of the geometry to deform at all, right? And so it makes sense that there's 0 deformation. Whereas on the right-hand side, right, you can see here that we have maximum deformation, right? And then, in fact, we have a deformation of about 2.57 millimeters, right? And this makes sense because this is the part of the geometry where we're applying our tensile force. Okay. Okay. And so because that's the place where we're basically pulling on it, right? And so and so the situation you can kind of imagine that this, like, you have the Hulk that's basically grabbing this plate and kind of trying to rip it apart just like that. Okay. And so by applying that tensile force right there, then this should probably be where most of our deformation is going to occur, or our highest deformation, I should say. Okay. And so that's what we see here. And so that again makes sense, right? And then everything in between those two are different levels of deformation, right? And so we can see here that we have the most deformation on the right, but all the areas in between the right and the left side have kind of mild levels of deformation, right? And so you kind of have this kind of gradient that kind of goes from the right to the left side, from maximum to minimum, okay? And so, when you get your finite element results like this, interpreting the colors and interpreting the legends is, really important to, to viewing the results, because each of the different colors basically mean a different, a different kind of result. And this exercise that I just did now, where I kind of talk through the results and I kind of try to make sure that it made sense. This is a really important step, because whenever you run finite elements, as you saw in this activity, there's a lot of steps that are involved to running a finite element simulation. And so you want to make sure that you're doing these kind of sanity checks after you run the simulation to make sure that your results make sense. Because it's very easy to kind of run a simulation like this and kind of trust the results at face value. But if they're giving you kind of nonsensical results or results that don't make sense, then you need to be aware of that, so that you can update your maybe your mesh is wrong, your boundary conditions are incorrect. Okay. All right. So now let's look at the stress. Okay. And so remember what we expected was, because of the geometry, we expected to have some stress concentration around the hole, right? And so that's exactly kind of what we see right here, right? So actually, let me zoom in a little bit just so you can see a bit better. Okay. All right. And so you can see here that the, around the hole right here, we have stress that's concentrating right here and stress that's concentrating right here, right? And that makes sense. And that's kind of what we expected. And that's why we refined the mesh around the holes to begin with, right? And so that again makes sense. And again, let's look at the magnitudes here. And so we can see that the maximum stress is about 8,371 megapascal, right? And so that's occurring, in this kind of very small, sharp area right here. But most of the plate is actually has very little amount of stress. And so you can see here that the difference between the maximum and the minimum is quite large, right? And so the minimum amount of stress here, which is only about 8 megapascal, which are all these kind of dark blue regions here, okay? And that's basically like no stress at all, okay? And so the only places on this plate that are actually feeling stress are the tops and bottoms of the hole, okay? All right, and so that seems to be in order. Okay. Any questions on the simulation results here? Okay. All right, and so that's basically the end of the activity. And so once you have the simulation results, you should be good to go for the rest of the activity. Okay. And so the rest of the activity, part of the activity is, I want you to interpret the results. Okay. And so whatever result that you get, I want you to interpret it to make sure that it makes sense to you. Right. So using kind of the same approach that I talked about here, talking about the deformations and everything, just to make sure that they all are lining up. Okay. After you do that, for kind of what I call the base case, I want you to iterate on this. And so I want you to basically play with the settings a bit. So I want you to change the loading, and so change the magnitude of the pressure. I want you to change the size of the hole, change the mesh size, use a different element shape. Okay. And I want you to try removing the refinement. Okay. And so all of these are going to have some kind of impact on the results. And so I want you to kind of, play around with that just to make sure that, you can do that. Okay. Right. And then from there, I have some additional practice here. Right. So remember last Wednesday, what we did was we basically did a review, or we just kind of did a crash course in MATLAB. And so I have some exercises here for you to kind of practice your linear algebra, just to make sure that you can form these into a matrix form and then solve for their solutions using MATLAB. And I also have some programming problems here as well, that are kind of in the style of, of the code that we're going to write in this class, right? And so it's quite a bit to do. And so, I would definitely, get started on it, just to make sure that you're getting started on the right foot. And, and what I anticipate and what I kind of expect is that, the programming problems, they're going to be a little bit difficult for everyone. So, definitely start those early. And if you're struggling with them, please don't be afraid to reach out, and, and I'll be happy to help you. Okay. Any final questions on any of this before we wrap it up for today? Okay, all right. And so, once again, I apologize. I should have let you guys know that we're doing Ansys today so that you can have it ready on your computer. But hopefully, hopefully the PDF is detailed enough, and you can come back to the lecture recording later to kind of finish the activity. So, I apologize again that it wasn't as interactive as I wanted to be. But hopefully this kind of gives you a first taste of Ansys to take in from all the way from start to finish. Right? All right, so thank you everyone for tuning in today. I know what today didn't go as planned as I wanted to be, but I appreciate you guys' patience, and I appreciate you guys sticking around and viewing the whole lecture. So thank you guys for coming. I hope you guys enjoy the rest of your evening. I'll stick around. We did end early, so I'll stick around if you have any individual questions for me. And if not, I'll see you on Wednesday.
Thanks, Dr. Tran.
Yep. Thanks, guys.
Thanks, Dr. Tran. Please
Right.
make sure they give me my after hours pass. They're lagging on me.
I'll send them a reminder.
Did they already have you sign it?
Yeah, I signed it already. I signed it as soon as I got it, but I think it's probably waiting on Dr. No to sign it right now.
They don't understand the struggles, man. Okay. Thank you, Dr. Tran. I appreciate it.
Yep. All right, Ram, your question is, will I post solutions for the homework? Yes. So I'll be posting solutions for the homework, especially for like the programming, and later on, once we start doing like the math and the problem solving, I'll be posting solutions for that as well. As for the MATLAB portion, so for the homeworks for this class, I grade them on completion, and so everyone here is a grad student, so I consider everyone here a mature adult, and so I feel like I don't have to police the homeworks as carefully as I do for my undergraduate classes. And so if you make mistakes in the MATLAB portion, I'm not going to ding you on it, but I would definitely still recommend keeping up with it, because all the skills are going to build on each other, and if you kind of keep up with everything, you're going to be in a much better position when the final project rolls around, rather than not. So I'm not going to be checking it too carefully. If you want to get my feedback on the homeworks, I'm happy to give that. But if you keep up, then you're going to be in a good position later on in the class. Yeah. Yep. Thanks, guys. Yep. See you Wednesday, Ram. All right, Colin, I'm gonna sign off. I'll see you Wednesday.
Oh yeah, my bad. I was just on Katia stuff. Sorry.
All right, no problem. See ya.